Here we have another partial fractions decomposition example problem. So we want to evaluate the following integral, and this integral is particularly tricky because we have a numerator that is of the same power as our denominator. And we know that when we typically use partial fractions, we need to have our denominator of a higher power than our numerator. And so the first question we have to ask ourselves is, how do I get this denominator to be of a higher power than our numerator? And one technique is by doing long division. So here we'll do some long division where we'll divide x squared minus 1 by our numerator term, x squared. And so by doing long division, we'll take x squared divided by x squared, we'll get 1. And then 1 multiplied by x squared minus 1 is going to give you x squared minus 1. We subtract this from our original term, and we'll get 0 plus 1, and so our long division is complete. And we can rewrite this expression from our long division as 1, so 1 plus 1 divided by x squared minus 1. So this will be our new terms. So essentially what we've done is we've rewritten our original integral as a new integral. That is something we can evaluate. So here we know that the integral of 1 will just be x, so we don't have to worry about that. And now we're going to focus on doing the integral of 1 over x squared minus 1. And so when we evaluate this for integration, we can see that we'll have to use partial fractions decomposition for this term. So here we can expand this x squared minus 1 as x plus 1 multiplied by x minus 1. And then we can get our constants a and b as follows. So this will be our expansion for partial fraction decomposition. And then by multiplying this term to both of the terms on the right-hand side, what we're left with is 1 is equal to a multiplied by x minus 1 plus b multiplied by x plus 1. And so now we can choose x values that will ultimately give us zeros and isolate either the a or b term. So we can do that by selecting x equal to 1 to get our b term, and we can let x equal negative 1 to get our a term. And the last step is we can go ahead and back substitute our a and b into our original expression and take the integral. So this will be our new integral, where all I've done is factored out this negative 1/2, and you can see this is very easy to integrate, and this will be our solution.